3-Minute Science with Michelle, episode 20, walking through the chronicle of stereochemistry. D, L, R, S, and plus minus. Why so many labels? Stereochemistry feels like an unfinished puzzle. The pieces were not all discovered at once. Each generation of scientists uncovered just a few pieces of the picture. In 1808, Etienne Louis Malus discovered that light could be polarized. 7 years later, Jean-Baptiste Biot built a polarimeter and showed that some organic solutions rotate polarized light left or right, but he couldn't explain why. In 1848, Louis Pasteur noticed that under the microscope, there are tiny asymmetries between the tartaric acid crystals. Some crystals had left-handed facets, others right-handed. With tweezers and patience, he separated them into two piles, dissolved them, and found that one solution rotated the light left, the other right. When he mixed them, the optical effects canceled out. Pasteur has shown that molecules can be chiral just like our left and right hands, but there was still no naming system. Until 1891, Emil Fischer studied glyceraldehyde. He found two stereoisomers, but without X-ray crystallography, couldn't see their absolute 3D structures. So he arbitrarily labeled them D and L, and that convention stuck, and we still use it for sugars and amino acids. By the early 1900s, polarimetry was routine, and chemists began using the term plus for dextrorotatory and minus for level rotatory. But here's the catch: D does not equal plus and L does not equal minus. For example, D fructose actually rotates light to the left. Confusing, right? In 1950s, Cahn, Ingold, Prelog gave us a standard. Rank 4 substituents on a chiral carbon by atomic number. Higher number equal to higher priority. If isotopes are present, the heavier one wins. If ties remain, move outward atom by atom until the first difference appears. Count double bonds as 2, triple bonds as 3. Put the lowest priority group, usually hydrogen, pointing away. Then trace from priorities 1 to 2 to 3. If clockwise is an R, counterclockwise is an S. If hydrogen is pointing toward you, reverse the result. Stereochemistry was always there, but it took generations to gather the pieces and build a common language. With tools like the Cahn, Ingold, Prelog rules, what once felt messy now makes sense. So when you get frustrated with these systems, remember stereochemistry isn't about memorization. It's about applying the right system with the right instrument to reveal the invisible patterns that shape every corner of our daily lives. Thank you for watching. See you next time.